Up until now, we had to be really careful about what types of functions we could integrate, just based on there is no way to undo a product rule. And even harder, how do we undo a quotient rule? So there's going to be some different things that you can look for that might possibly have to do with multiplication or division, that sort of thing, if we can't just simplify it before we try to integrate. So some things to look for, and these are not perfect situations, but they are pretty helpful, I guess, if you get stuck and you're like, I don't know what to do. So first thing, look to see what's inside a root. So if you have a root, try to look at what is inside that root. What could we substitute out to make it easier? Look for the denominator of your fraction. If you have a numerator and denominator, neither one's like, hey, this one's going to make this a lot better, pick your denominator and do use substitution with your denominator. The argument of a trig function. So if you have a trig function, whatever is inside that trig function. So if it's the sine of 2x, then maybe you're going to look at 2x. Or if it's the sine of x squared, you're going to use maybe the x squared. If there's an exponent on e, if something is being raised to a power, or if something whose derivative is also in the problem. So when you kind of think through it, like look for that derivative piece. Now what we're looking at is how do we use substitution to make it easier, and then we have to go back through it. Because if I have x in my problem, I need x in my final answer when I integrate. I can't have a u. But we're going to use a u along the way to try to make it a little bit simpler. So here's what I'm talking about. Okay, so again, these are for indefinite integrals, and we're going to be doing u substitution with them. So what you'll notice is there's a product here, and then there's also this power outside here. So there's a couple of different things that are making this difficult. So one of the recommendations was to look at what's being taken to a power. And here's the thing, sometimes you're going to try it and you're not going to get anywhere. Try something different, see if that works. So what we're going to do is we're going to say, hey, you know what? Let's let u equal x squared plus 1. Okay, so now what we have is the integral of 2x times u to the 4th dx. Now here's the problem. We're taking the derivative with respect to x, but I have a u in here. I can't have both x's and u's if I want to integrate this. But here's how that's going to be fixed. Let's go ahead and take the derivative of this. Derivative. So I want to find derivative of u with respect to x, so du dx. So this goes back to when we first started calculus. What's the derivative of x squared? 2x. What's the derivative of 1? 0. So that's the derivative of this. Now if you rewrite this, what we're trying to do is we're trying to make this look like this, something over on this side. So therefore, what we're going to do is we're going to actually solve for du. So what we're going to do is we're going to multiply, in essence, both sides by dx. So therefore, we're solving for du. du is 2x dx. And the reason we did that, 2x dx, 2x dx, what does that equal? du. So therefore, when I substitute that back in here, I get the integral of u to the 4th, and then that becomes du. So now I'm integrating u to the 4th with respect to u. That's fine. My letters match up. So now I integrate this. So now I have to go back, and this is what sometimes gets students, is you're doing derivatives and then you're integrating all within the same problem. So you really have to think hard of what you're doing. This integral sign here means you need to go backwards. You need to find capital F of x. So this, therefore, is u to the 5th over 5. Don't forget your plus c. So I integrated u to the 4th. But I didn't want to integrate u to the 4th. I wanted to integrate this up here. That up there has x's in it. This has a u. So the very last thing that you have to do is you've got to go back over here and resubstitute that back in. So that ends up being, and I'm just going to pull out this 1/5. So this is the same thing as 1/5 u to the 5th plus c. Okay, so now, last step, get rid of that u. So that's 1/5 x squared plus 1 to the 5th power plus c. And that's the integration. Cool, isn't it? Okay, let's do another one. Scary one. We're doing a sine. But do you see how there's this product inside here? We can't really simplify that down. Now in the last one, if we really, really wanted to, we could have expanded this. We could have written x squared plus 1 out 4 times and multiplied those all together and multiplied it by 2 x, and then simplified it down that way. I could have done it that way. Not a very easy way to do it though, especially when you have time restraints. So here in this one, again, this is a product. I can't expand. I can't do any of that kind of stuff with it. So now I need to figure out what u substitution do I need to do. So we're going to say let u equal, what do you think? We have a trig function. The argument is not just x, it's x squared. So let's pick x squared. I could have tried the sine of x squared, and then as I go through, if nothing simplifies or nothing rewrites, I can't use it. Then I have to try something different. So now I have this, so now we're going to take the derivative of that. So du dx is just 2x. So therefore, solving this, du equals 2x dx. Over here, this is the integral of x times the sine of u dx. So I just did that u substitution in there. And what you're going to look for now is that 2x. And what you're going to notice is you don't have a 2. You just have an x dx. So I have an x, and then I have a dx. So get rid of that 2. Divide it over here. That's a half du equals x dx. So now, in place of the x and the dx, we're going to have to write in there that 1/2 du. But the sine of u is still there. So we still have the sine of u. And then I have that 1/2. I'm going to just toss this in front of the sign. And then this is du. I can integrate this. You remember integration rules? The 1/2, that constant can come out front here. So it's a half the integral of the sine of u du. So now I have to integrate the sine of u du. And integrating the sine, so half is out here, and integrating the sine of u is the negative cosine of u plus c. And then I've got to substitute back in. I can't have that u. U was x squared. So therefore, I have negative 1/2 times the cosine of x squared plus c. Going okay? So it's kind of a process, but this is where I talked about, for those of you who had me for Algebra 2, we talked about we do u substitution because sometimes we have to do u substitution. Otherwise, we can't do the problem. You can't do this problem unless you do substitution. So this is a substitution that we're working through. Okay, next one. 2 trig functions. So if you go back to our recommendation, I have 2 trig functions. Both of their arguments are x. So the denominator of the fraction. If you're not sure what to do, try to set u equal to the denominator of the fraction. Now if it said the sine of 2x, then maybe I want it to be 2x. Okay, and maybe I'm going to try to undo it that way. But it just kind of depends upon what you have and what you see. So therefore, u is this, so therefore du dx, derivative of cosine is the negative sine of x. So then solving that over, du equals negative sine of x dx. I'll do my substitution. So this is the sine of x over u dx. You're close. You almost have the same thing, just this negative sign. So divide both sides by negative. So the opposite of du in essence, or negative 1 times du, equals the sine of x dx. So substituting that in, this right here, I just put the negative in the front. Negative multiplier, that's it. So it's equivalent. Bring that negative multiplier out. That's just a negative 1. I can integrate 1 over u. Hopefully you remember. Integrating 1 over u is the natural log of u. Plus c. Now one of the things that we haven't really touched on a lot is, remember natural log? This argument has to be positive. Therefore, whatever u is, we take the absolute value of it to make sure that it's positive. Okay, so I've got to keep going through here. So this is the opposite of the natural log of the cosine of x plus c. Okay. I can leave it that way. That's perfectly fine. I just have an x in there. I integrated it. One other thing, if you remember log properties, my Algebra 2 folks are doing this right now. This, remember, is a -1 in front. So again, totally fine answer, you could leave it here. But if they said which of these could be possible solutions or something like that, you can have multiple situations. So a negative multiplier on a log becomes the exponent. So this is equivalent to the natural log of the cosine of x to the negative first power plus c. So that's my argument, is the cosine of x. Cosine of x goes to the negative first power, which means this is equivalent to natural log of 1 over cosine of x plus c. And hopefully you remember what the reciprocal of cosine of x is. Secant is its reciprocal. So that would be a perfectly fine answer as well. So either of those two work. They both are simplified. They're both completely acceptable. So we're going through a bunch of integration. This is not in your textbook, so you're going to end up getting a worksheet that goes along with this. Again, the most challenging part is figuring out what u needs to be. And you may do a little bit of trial and error. You might try something and it doesn't work. It doesn't easily simplify in. Or you can't just get a du. Okay, you end up having an x in there as well as u's. So there's going to be different situations that will happen, so just be careful and practice through those.